Hello students, welcome to the world of chemistry. This is Dr. Vikram Panchal and I'm dealing with spectroscopy for chemistry. This is lecture number 30. In this lecture, I will explain you solvent effect in carbonyl compounds. If carbonyl compound is present, that is C double bond O, then N2 pi star transition is possible. And suppose this is N orbital, this is pi star orbital. The n orbital has lone pair of electron, plus electronegativity of oxygen is more than carbon. So it is partly delta minus delta and carbon is partly positive delta. So we can say this is comparatively more polar than pi star state. This is less polar. Now, in carbonyl compound, due to, let us write something. In carbonyl compound, due to more electronegativity, of oxygen, N state, that means N orbital, is more polar than pi star orbital. Now, in presence of polar solvents, like H2O or ethanol, there is an interaction between solvent and carbonyl group, which stabilizes and reduces energy of both N and pi star states. So what happened in this case? Let us see this one. That this negative oxygen of carbonyl group attract positive hydrogen of polar group, polar solvent, maybe alcohol or water, because hydrogen is partly positive, oxygen is partly negative, and they will form intermolecular hydrogen bonds. So this is intermolecular hydrogen bond. And therefore, stabilization of N state as well as pi star state is possible. Okay, because of the interaction between N state and hydrogens of solvent. Okay. So now, in this case, energy of both N and pi star state will be reduced. But as N state is more polar than pi star state, because electrons are in N state and oxygen is negative. Therefore, polar solvent shows more interaction with N state than pi star state. Therefore, reduction in energy of N state is more than that of pi star state. So let us see this figure once again, that N state is more polar than pi star state. So here both state will be reduced and therefore there will be reduction in energy. Suppose this much is the reduction in pi star state. So now new pi star state is somewhere here because of reduction of energy. So this is pi star state, okay, with new energy because of the interaction with solvents. But the reduction of N state would be more than pi star state. So here we will see N state over here. And now here you can see that reduction of energy of N state is comparatively more than pi star state. So here we can say it is less reduction in energy and here more reduction in energy. Okay. So now new N state in case of polar solvent. So now transition takes place from N to pi star like this. But here you can see the gap, energy gap between N and pi star state is comparatively more. So here we can write delta E2 or absorption of wavelength of lambda 2. Okay. So here it is very clear that this is in polar solvent. Okay. And we have new state. And in this case, it is very clear that the energy required for N to pi star transition is comparatively more than energy required to N to pi star transition in non-polar solvent. So this is particularly in polar solvent. Okay, so it is in polar solvent and it is N to pi star transition again. Okay, so here it is visible that delta E2 is greater than delta E1. That means lambda 2 will be less than lambda 1. That means lambda maxima decreases. So the graph will go towards blue shift. Okay, so it is also considered as a blue shift because of polar solvent. So this is the effect of polar solvent on N to pi star transition, and that is because of the hydrogen bonding with polar solvents. Okay, so here we write that in this case, this will lead to more energy gap between N state and pi star state. Therefore, N2 pi star requires more energy or radiations of shorter wavelength. Why? Because delta E2 is greater than delta E1, or we can say lambda 2 is less than lambda 1. So thus spectra will shift towards left side, that is blue shift or hypsochromic shift. But this hypsochromic shift for N2 pi star transitions. Okay, so in that case epsilon value will be very less. Thus, when UV visible spectra of enone or benzoyl systems which contain carbonyl group is recorded with polar solvents, then the value of lambda maxima decreases than what we expect. Okay, so this is the solvent effect on N2 pi star transition. Okay, so here we can see solvent effect in case of N2 pi star transition. So this is about N2 pi star transition. In next lecture I will explain you pi to pi star transition also. Thank you so much.